So welcome back, and we are carrying on with our study of functions and inverse functions, logs, right? And what we were busy with last time is finding the equations of some functions. Right, let's dive straight back in. Over here, what is this? It's a hyperbola. The standard form for a hyperbola is y equals k over x. I'm expecting k to be negative because it's in those two quadrants, but let's not worry about that for now. This graph has been moved. How do we know it's been moved? Well, because the asymptotes are at -2 and at -3. This graph is actually the normal graph, it's k over x, but it's been moved 2 to the left and 3 down. Now, how are we going to move it 2 to the left? What are we going to do? We're going to add 2 to the x. How are we going to move it 3 down? We're going to subtract 3 at the back. Every single hyperbola with those asymptotes has that equation. Okay, now we want the specific one that goes through that point there. So what we're going to do now is we're going to sub that point in and get our k value. Right, let's look at how this is going to look. We're going to get -4 equals k over 2 plus 2 is 4 minus 3. We're going to add 3 to both sides. We're going to get -1 is k over 4. We're going to multiply both sides by 4, and we're going to get k as -4. Our final answer is going to be -4 over x plus 2 minus 3. That's the equation of that hyperbola. The next one, what is it? It's an exponential graph. The vanilla flavored form is ab to the x. This one has moved up. How do I know it's moved up? Well, because the asymptote is at 3. So this one's going to be ab to the x plus 3. Next up, remember what we said, we'd solve ourselves a whole lot of difficulty if we use the y-intercept first. All right, let's take a look. We're going to put 0, 2 in, remembering 2 is the y value, 0 is the x value. Okay, this becomes 2 equals a plus 3. Subtract 3 from both sides, a is -1. Okay, next thing and last thing we're going to do is we're going to substitute in the other point, right, into this equation. -1 times b to the x plus 3. Now we're going to put that point in, and that's -1 is our y value, equals -1 b to the -2 plus 3. We're going to subtract 3 from both sides, right, giving us -4. -4 equals b to the -2. So in fact, b to the -2 is +4. b to the -2 equals 4. Now, I'm sorry we're running a little bit out of space here, all right? But b to the -2 is the same as 1 over b squared. So 1 over b squared is 4. So 4b squared is 1. So b squared, and I'm sorry I'm leaving out some lines here, b squared is 1/4. And when we square root both sides, we can normally have plus or minus. But remember that our base cannot be negative. So in fact, our answer is actually b is 1/2. All right, our final answer for this one, and I'm apologizing for the space, is -1 times 1/2 to the x plus 3. Okay, now I want us to think about this. Let's just start with this graph as the most basic graph like that. Okay, there was a negative here which I didn't want to rub out. I wanted to just put a line through for now. Okay, 1/2 to the x comes downhill. What does that negative do to the graph? It reflects it so that it now goes uphill. Okay, and that's why we can see it's now going uphill. And what does the plus 3 do? Well, the plus 3 actually shifts it up 3. That's why that graph has that equation. Okay, right, I'm sorry about the lack of space there. Right, this next one is a log graph. We've actually been told it's a log graph. We know the base is going to end up being bigger than 1 because this graph's going uphill. We also know that this graph has actually moved 3 to the left. How do we move a graph 3 to the left? Well, we add 3 to x. Okay, now the last thing we're going to do is find out what our base is. We're expecting our base to be bigger than 1, and the way we're going to find our base is to substitute in this point, right? So we're going to get 2 equals log base b of 1 plus 3. Right, we're going to take this out of log form into exponent form. B is the base, it's always the base stays the base. B squared equals 4. Now we square root both sides. Remember, the base cannot be negative, so the only possibility is that the base is 2. B is 2. Remember, we said we expected the base to be bigger than 1 because this graph's going uphill, left to right. So our final answer, log base 2 of x plus 3. All right, and our very last one that we're going to look at now, okay, is this one over here. What is it? It's a parabola. The basic form, the vanilla form for parabola, ax squared. This one has been moved. All right, it hasn't been moved. Ax squared would be over here. It would turn at the origin. It hasn't moved vertically, but it has moved horizontally. It's moved 4 across to the right. How do we move a graph 4 to the right? We subtract 4 from every x. Okay, the last thing we need to know is what is a. The way we're going to find that is we're going to sub in that point. 6, negative 2. Y is negative 2 when x is 6. 6 minus 4. Right, what we get here, this becomes 2. 2 squared is 4. So we actually get 4a is negative 2. So in fact, a is negative a half. Last thing we're going to do is we're going to square it all out. So we're going to work out what is negative a half lots of x minus 4 all squared. Okay, and that's not difficult. X squared multiplied by negative a half x squared. This is going to be negative 8x times by negative a half is positive 4x. This is going to be 16 times by negative a half. It's going to be negative 8. Just it'll kind of give ourselves a warm feeling inside. Negative 8 is meant to be the y-intercept. Yeah, that looks about right. This point over here is probably negative 8. Okay, so it looks like it could be correct. It is correct. Okay, this next question is an interesting question because we're now getting into the whole notion of interpreting functions. Okay, and we're gonna show you 2 ways of thinking about this next question. We're talking about f of x, which is this graph over here, and we're talking about equals k. Right, so I've written that k in red for a reason. Think about the line y equals k. Y equals k is a horizontal line. Okay, and we are asking about this graph equaling this graph. We're asking about the parabola and this horizontal line. Okay, and when will we have real and unequal roots? In other words, when will those graphs intersect one another at 2 different values? And the answer to that, obviously, if we move this line up, if we think about y, if y was equal to minus 6, the graphs, like it looks like it could be at the moment, the graphs would miss one another. But if we pick this up, suppose it was over here. Do you agree we've got 2 real and unequal roots? Okay, so in fact what we need is we need k to be bigger than negative 5. Right, because as long as k is bigger than negative 5, this line will be above and it will cut the parabola twice. The next question says, when will we get equal roots? Okay, and we will only get equal roots if this line y equals k is exactly going through this turning point. Now we're only going to get, two equal roots or one root. Okay, and that will happen if k is equal to negative 5. Okay, so that's one way of thinking about this. I'm going to give you another way of thinking about it. If we've got f of x equals k, then that's another way of thinking about that is to say f of x minus k equals 0. Now f of x is just our function, right? And we're wanting our function to equal 0. Now at the moment, the function has got real and unequal roots where it equals 0. Okay. Do you agree that if we drop it down, it will still have real and unequal roots? And even if we pick it up a bit, it will have real and unequal roots. But how much can we pick it up? How much can we pick it up so that it will have real and unequal roots? Okay, we can't pick it up more than 5, right? So if we want to pick it up, then we actually need, think of this as a vertical shift. This is quite difficult to understand maybe, but think of this as moving the graph up and down. Now, if k is positive, the graph will move down because it's going to be minus a positive number. To move it up, k would have to be negative, right? And do you agree if for example, k was minus 1, then it would be minus 1, the graph would move up by 1, all right? So we actually, k minus 3, it would move up by 3. We want to move it up, but we mustn't move it up by more than 5. And because of that, k must be bigger than minus 5. Okay, that's for part 1. Okay, for real and unequal roots. If we wanted to get it so that this parabola only had one root, we would have to pick it up by 5. And to pick it up by 5, we'd need k to be minus 5 to give us a minus 5. All right, so another way of thinking about it, but leading to exactly the same answers. Okay, that is tricky. I know it's tricky and it takes a bit of getting one's head around. Okay, we're going to look now at another question. Okay, this here is going to, is that going to be a horizontal shift, left, right, or a vertical shift, up, down? Okay, it's going to be a vertical shift. Right, now, at the moment, this function has only one intercept. It has only one root. Roots are also called x-intercepts. Do you agree that if we pick this graph up a little bit, okay, then it would cut the axis at 3 places? Right, but if we picked it up too much, it would only cut at 1 place again. All right, and we want to pick it up a bit so that it has got 3 different x-intercepts. 1, 2, 3. Right, so let's think about how much we could pick it up. We could pick it up. We would need to pick it up by more than 0.615. Okay, but because this is a minus, we actually need negative 0.615. All right, so negative 0.615. We need to pick it up. We need t to be bigger than negative 0.615. So for example, if t was negative a half, no, that wouldn't be enough, right? We actually need t to be less than negative 0.615. Okay, t must be less than negative 0.615. I'm just going to put a number in here to try and help us. Suppose t was negative 1. Do you agree if t was negative 1, we would get negative 1, we'd get plus 1. We'd pick this graph up by 1. And this point would now be above the axis here, and we'd have an x-intercept and another x-intercept and this other x-intercept. Okay, right. But we can't pick it up by more than 1,385. So in fact, t must be bigger than negative 1,385. Right, this requires quite a lot of thought. I want you to pause the video, stop, discuss it with one another, chat about it, argue about it. All right, but there is the answer, okay? And just see if you can make sense of that. Take a number in between these two numbers. For example, negative 1. Negative 1's a nice, obvious one, because at negative 1, this whole graph will shift up by 1. And the reason it will shift up by 1 is because of the minus, okay? So it'll become plus 1. But if, for example, we went negative 2, all right, which is not inside here, negative 2 wouldn't work, it's not inside here, then it would be subtract negative 2, it would actually be picking this graph up by 2, and now the graph would be right up here, and it would only have one x-intercept. Okay, quite tricky, but as we practice it, we'll get better at it. We're going to stop there. Before the next lesson, we want you to try question 28. All right, at least 28, but maybe 29 as well. We'll go over them next time. Have a great day.